Hey, my name is Jay Gordon. Welcome to Modernizing Your Application with Containers. I hope you're doing well, I hope you're feeling safe, and hope your family's doing great. So why don't we go ahead and learn a little something today. I hope you will get a lot out of this and maybe even use some of the code to go ahead and build this yourself. So why don't we go ahead and get into it, all right? So first of all, my name is Jay Gordon. I live in New York City. I am a cloud advocate with Microsoft. If you'd like to follow me on Twitter, you're more than welcome to. If you'd like to, there are some resources. This is a great time to take a screenshot. I will make sure that you get the slides after our presentation, but these are places that you can go to get resources on the session, or if you want, there's $200 worth of free credit for Azure if you sign up today. This is for new accounts. So let's talk a little bit about the goals for this session today. First of all, we're going to talk a little about Docker, containers, registries, and a little bit more. So the skeleton of what's going to make up the infrastructure of our application. We're going to modernize our application with containers. We'll review the available endpoints for migration, and then finally we'll go through a demo. So I'm going to show you actually how to use these services, and we'll build something today. And you'll be able to do it as well if you'd like to. So the first question I'd like to ask you, and I think it's the most important throughout this entire presentation, is where are your apps? And I don't mean the application store. For some of you, applications may be still hosted in pretty big data centers with tons of redundant power, air conditioning, security, all those really important features that we really depend on to make sure that we have reliable systems. But are you really in the business of maintaining hardware? Because a lot of us end up building these beautiful looking data centers, but they don't really last like that. And then we may go to virtual machines, and virtual machines are absolutely perfect for many use cases, but we start to overutilize them. We get into situations that we have to manage them, and you could be spending a ton of time on managing backups, patching, and ensuring your deployment method is working. So while everyone's out there kind of enjoying life, you're spending your time, you're checking your alerts, monitoring your apps, you're fixing them because of on-call situations, and you're losing time. And so you're making things a little bit more difficult for you and your team and probably your customers. So let's make peace with your infrastructure today. Let's make that feeling of deployment bring calm to you. Let's discuss why we want to change our environment for deploying to a new place for our application. So let's get you on a path towards application Zen. We'll begin by asking what are the big problems that we want to solve in our existing environment. And so that's really important. If we're going to change something, there's got to be a real reason. Well, when you host in the data center, let's talk about those big three reasons why we want to move out. First of all, cost. There's no more large capital expenditure that we would have to put in if we move into the cloud. Costs are a main driving factor for many people that make that migration. Then there's assumed scale. There's this really great song that I like by the band called Steelers Wheel, and it's called Stuck in the Middle with You. If you've seen Reservoir Dogs, you may recognize it. And assumed scale means that we're kind of stuck. We've made a decision. We're stuck in the middle. If we grow, we have to go out and we have to purchase additional equipment. If we shrink, we've got to do something similar, and we actually have to have hardware that we're not going to be using sitting around in racks and data centers. And then we need to consider our compliance and regulations. Many of you may be working with GDPR, you may be working with government regulations, maybe even private or personal information like PII. If that's the case, you may want to not think about a data center because you're really having to do all this work yourself. And so virtual machines are great, but let me ask you the question, do you really need the entire thing? Let's face it, you have an entire operating system to manage, which means more work, longer startup time. And when I say startup, not just the boot up of your virtual machine, but the amount of work that you actually have to put into getting it ready. So you may actually have to be working with something like, let's say, configuration management, Chef, Puppet. You're having to write some stuff for your DSL. You're doing all these things so that you're able to deploy to your VM, but the process is going to take you a little longer. And then there's just simply more things to monitor. There are more outputs, more data produced by the virtual machine. So you have to really consider more things to monitor throughout the process. So we're going to talk about modernization with containers. And containers aren't a replacement for virtualization. It's a new way to package, version, and manage software releases. This is a big idea you really need to consider. So let's talk about what a container. Well, if you peel away the hype behind containers, all that's really left is the simple truth. Containers are a standardized way to package your application, its dependencies, and the runtime environment into a portable container. And that can be run anywhere with the same outcome. So containers allow for repeatable deployments regardless of the host environment. And containers only need to be provided with runtime data, like connection strings, in order to run. So, why containers? I mean, let's really put it simply. I mean, they give developers the ability to create predictable environments isolated from other applications. So, works on my machine, and every dependency needed by an application, versions of the runtime, libraries are all included in the container and guaranteed to be consistent regardless of where the image is deployed. So, works on my machine, and every environment looks the same because we're building it into a container. That image is going to look the same no matter what environment we put it in. And that means increased velocity, and that equals productivity. So developers and ops teams spend less time and less cycles debugging and diagnosing environment issues, and more time pushing features and enhancements to users. And one of the big things, like I already said, you can run anywhere. And when I say run anywhere, I really do mean it. Containers run anywhere, easing the development and deployment of applications. Windows, Mac, Linux, cloud, even IoT. That's right. If you're going to build anywhere, the widespread popularity of the Docker image format for containers helps the portability. So wherever you want to run your software, you can likely use containers. So the container format is an open standard called OCI, and it's not constrained to a single vendor. It's got less overhead and higher performance because images and containers, they share many resources with the host rather than duplicate them like the VM. So we're not creating a virtualized kernel or anything like that. So there are fewer isolation guarantees. Containers use namespaces and C groups. They provide isolated resources. We have a shared OS kernel that's a key differentiator. Windows containers are virtual machines, and some container runtimes isolate containers using VMs as well as Kata containers as an example. So it's just a process on a computer. So I want to show you, this is a really great kind of comparison of what a virtual machine looks like. And if we see here, we'll start at the very bottom. This is the infrastructure. These are the servers, the physical machines that we have. Then on top of that, we actually have to have a host operating system. We have to manage that operating system. We have to manage, patch, and do all the things associated with that operating system that we would expect for any other computer. Then we have a hypervisor, something like VMware, or any other type of hypervisor. This or even Hyper-V. These are things that are actually providing the virtualization between the computer and what is eventually the guest operating system. So this is creating the virtualized computers, and from the guest OS, which much like this host operating system, we have to patch, manage, backup. We've got to do that here as well. And then on top of that is our binaries and our libraries that actually provide dependencies for our app, and then we've got our app. So that's a lot to manage. Whereas this is the side where we look more at containers. And so a container provides you with the infrastructure, or I should say the infrastructure is the main part of the container, just like we are with a VM. Then we have the operating system. And the operating system isn't a host operating system. It is the operating system for the containers. And the container engine eventually handles all the things that would have eventually be done by the hypervisor. But it's just a Linux process or something of that nature, like a process for that particular OS that runs on top of it. And as you can see, the container engine now lets us run our app. What's Docker? We're going to talk about that next. And it's the most popular container runtime. And you can start building apps, testing them in Docker and environments on your computer. And really what happened was there was a company called dotCloud. They came up with this idea of Docker and containers. And they essentially created an API that just made it more elegant for developers to use to deploy. And they created the portable image format. And the great thing about the portable image format is it's just a zip file. They just changed the actual file extension, but everything's pretty much contained into a zip file. So this is a brief look at what a process to create a container would look like. And so since there's no such thing as a Linux container in the kernel space, containers are various kernel features tied together. When you're building a large platform, a distributed system, you want an abstraction layer between your management code and the syscalls and duct tape of features to run a container. That's where Containerd lives. It provides a client layer of types that performs, can build on top of whatever, or without ever having to drop down to the kernel level. So it's much nicer to work with, a container task and snapshot types, than it is to manage calls to clone or mount. So what's a Docker file? Well, it's a text file, and the text file contains instructions on how to build the image. So each line is either making changes to the root file system or the metadata associated with the image. Each line in the file also results in a new layer being created in the image. And if you're more interested in the container image, you can check out the spec. It's on GitHub under the Moby repository. So this is an example right here of what a basic Docker file would look like, but let's look a little bit deeper here. So by using Docker, we essentially can show in this example, we're going to be using Python as the runtime, as well as what we're going to be doing is building our directory within the app directory. We're going to copy it. We're going to run pip install. We're going to expose port 80. We're going to create a environment variable called name that with the key world, and then eventually we'll run the Python app. So we can use simple scripting to tell Docker what you need. And if you want to look at it, like I said, this is the spec. You can customize it based on what you need. So what's a build? A build is the action of building a container image. So this is what happens when we actually want to create an image based on our code and then put it in that zip file. We need to build it. So all the things that we need to put into our container is done that way. And so here's an example of doing a Docker build -t. It's going to build our application with the version number and then specify the directory it's in. And so this is using just local Docker. It's going to go ahead, build everything we need. Cool. So what's a repository? Well, we work with code. And when we need to store code somewhere, we put it in a repo. And we kind of do the same thing with Docker images. We label them with tags. We give them a specific image version with it. And we can use different platform variants and put different image types in the repository if we need to. So here's just an example of looking at the repo. Real simple, one command. This is the one stored on my local computer. So what's a Docker manifest? A manifest is a list of the layers and the image layers that are created by specifying one or more image names. So what you can see here, and this is a great example of what it looks like when you see a Docker manifest. You can see that each layer has a hash, information on the architecture and the operating system, and the layers that make up the container. And we can actually pull each individual layer if we need. We can see the different zip file what it's contained in. So we've got a whole bunch of information. So what's an Azure Container Registry? Well, we need a place to put that repo. And it's a public resource for working with Docker images. So Docker created something years ago called a registry on the hub. That's where you could keep your images. There are public images for use, but if you want to use something private, you can create an Azure Container Registry for a private registry. You can store all your individual Docker images, and then you can actually go right here and pull out your image if you need it. See right here, that's the actual location. If I wanted to, I could just copy that and I could put that into my terminal and essentially pull the image specifically and test it locally if I wanted to. And so this is just what it looks like to actually log into a Docker registry. It's pretty simple and allows you to authenticate with the username and password that they provide you. And then here's me doing a simple build on an image. So what's an Azure Container instance? So these are kind of like unorchestrated containers. They're really, really simple. They're containers as a service. If you need to run a container without a lot of orchestration around it, this is perfect for you. You can attach persistent storage. You'll get a public IP. You can use Linux or Windows. I think this is a great idea for people who are starting to get interested in using containers, but don't necessarily need to do a lot with them. So if you want to just do a test of an individual app, you need a container, you need to test it in the cloud because maybe someone else needs to use it, this is a good option for you. So let's create an instance using the Azure CLI of an ACR, or Azure Container Registry. So as simple as we create a resource group. A resource group is a group for our resources. It's a standard logical unit of Azure. And then what we do is we're going to create, not the ACR, I should say the ACI, pardon me, the Azure Container Instance. And to create an Azure Container Instance, we just provide the container location. And so we named it My Container. We give the image of the Hello World located in the Microsoft repository. We give the resource group that we just created, and then we have this IP address that we asked for, and so we'll have a public IP attached to it. And so like I said, we'll create a resource group, we'll create the container, and then we'll have the instance container. I need you all to hold on a second. I just got a alert. Let me pull up my phone and take a look at my alert here. I think I'm going to share it with y'all. Give me 1 second. Tailwind Traders. Tailwind Traders is one of the world's most popular fake companies that Microsoft has ever created. Well, I just wanted you all to know that today, Tailwind Traders Incorporated has announced that they have agreed to acquire Northwind Traders, another old guard company, and that means that the world's biggest fake company is now upon us. Let's give them a little bit of applause. I think that's great. I mean, if you're a fan of these big fake companies, congratulations. Now you get to root for them to be successful together. But there's a catch. When you get all this money and you've got a new kind of idea of things that you need to take care of, you sometimes come along with more problems. Technical debt. You know, you take on something that maybe has been held together with shoelaces and gum and a little bit of saran wrap for years. And that's that technical debt. And maybe that's kind of one of the things that we're going to be dealing with next. So I'd like you to meet Jill. And she's the new CTO, the newly minted CTO of Tailwind Traders. And Jill has informed the IT organization that she received from the board a mandate that has informed them that they need to make some changes over the next 12 months to see greater profitability. And to do that, what Jill has really told them all they need to do within the tech team is to move to an elastic solution. So when I say elastic, it needs to grow and shrink with the company. We need to reduce our team's responsibilities and offload a lot of the work that they've been doing to services. And then we need to modernize for a more rapid deployment by using containers. So we'll get started by using what is their application to move it into the cloud. It's going to be made up right now of multiple VMs. Those VMs are currently hosting MongoDB for NoSQL data. That's a portion of the application. Stores its data there to be able to get information on products. Then we have MS SQL service for our SQL data, and that's where our transaction information for our products and purchases are going to go. So every time someone purchases something, that's where all the data is stored. And so it's made up of two specific code bases. The APIs are deployed in .NET Core, and then there's React that handles the front end in JavaScript. So that's what we're looking at right here. So Jill made a decision, and she wants to use App Service for Microsoft Azure because that's going to clearly fit the needs for the business, because it's going to be a fully managed application platform. They'll be able to deploy their stack using Node, PHP, .NET, Python if they want to, but we'll be using containers specifically today. I'll show you how we can do that. We can support custom domains, SSL, single sign-on. We can plug into other major services, and we'll talk about that just in a second, like load balancing, CI/CD with Azure DevOps, or maybe even GitHub Actions. And then we can implement managed databases. So one of the things that we're not going to do in this talk is we're not going to be migrating the databases. That's another discussion for another day. But rather than use MongoDB on a VM, what we're going to do is use Cosmos DB, which is a globally distributed database service. So we can use global distribution, scale out, guarantee low latency. We have all these different types of documents, and column family, key value that we can store, or even graph data. We have all these different types of APIs that are supported to query this data. So that's where we're going to be storing the NoSQL data. And then what we're going to do is we're going to store the Azure SQL we're going to store our SQL data in Azure SQL database. So we're going to use a fully managed database platform rather than just managing it on a VM. So we've done a lot of that work already. I've done the migration as far as the database is concerned, but let's show you how to modernize the container. So what we're going to do is containerize the app. We're going to create and upload an image to an Azure Container Registry, and then we're going to deploy the application to Azure Web App Services. So let's demo. Let's build a container. Sound good? Great. So what we're going to do is we're going to do this kind of two-pronged. We're going to use the Cloud Shell. Let me reconnect that. And we're going to use the portal. And I've got some notes that I've already got ready. I'll be using those to kind of help us build what we're going to do today. So once our Cloud Shell opens up, there we go. We can either go to shell.azure.com, or if we wanted to, we can go right here and click this, reconnect, open up our. So the first thing we are going to do in this process is we're going to create a resource group. What is a resource group? It's a group for our resources. So I'm going to just set a couple of variables for the environment. And so I've just set our resource group name. So when we create, we have our name. ACR, when we create that at some point. The subscription we're going to be doing everything under. And the region we're going to be doing all of our work. And in this case, its location is East US. So let's go ahead and create a resource group. And doing that is pretty simple. AZ group create subscription, the subscription name we've got here, and the resource group and the location. All the output is in just standard JSON, tells us all the stuff that we've just created. Great. So now that we've gone ahead and done that, what I want to do is grab my code. So let's go ahead and grab the code. Let's go into there. Great. So what we're going to do is clone this repository right here. It's just the Tailwind Traders application. It's where it's all hosted. If you want to use it, you can as well. We can see here, if we go into source and we go into Tailwind Traders app, we'll see the entire application. The Docker file we'll need to build our app and everything else. So let's go back here And let's just clone this repo. Okay, that's just going to take us a second. And so while that's cloning, what I want you to see is the next step. And so we've got our resource group. It's created here. We've got our code cloning. Great. So now that our code is done cloning, what we're going to do is we're going to create an ACR, an Azure Container Registry. So this is actually where we're going to store our image once we create our Docker container image. So it's as simple as running this AZ group create subscription, the name of the actual resource group, the name of the ACR that we want, and the location it's in. So here's all this information that we have gone ahead, that's the group create. So let's go ahead and create an ACR. So creating an ACR is just as simple as this right here. AZ ACR create the resource group, the group name. Let's back it up a little bit just so we can see that again. And you can see all the information gets output again in JSON. AZ ACR create the resource group that we had in our variable, the name that we want to give it, the SKU, basic subscription, the subscription name that we're going to be doing it, and then admin enabled true so that we can actually log in using our username and password. Great. So we've done this. We've created a place to create our image. Now we actually need to create our image. And so if we go into VCA Demo Live, we'll go into Deploy. And what we'll look in here is some deployment information if we were going to use something like an automated script through Azure Resource Manager. But today, we're going to just go into Source. We'll go into Tailwind Traders Web, where their actual code is located. Great, there's where our Docker file is. If we cat Docker file, we'll see what we're building. We're building a Node 10 Alpine image. We're installing our app. So we're doing a multi-stage build. So we're able to do a number of different actions in this container that will build both the .NET environment and API, and then eventually build our React front end. So to actually get this container built, what we need to do is just create a container registry, or I should say a container instance. And what's really cool is that this container instance that we're going to use today is going to be managed by Azure. So we don't actually have to build using Docker build -t or anything like that. What we're going to do is just use a command that's built into the AZ CLI, and here we go. So what we're doing right here is building our image, and what we've told the process to do is AZ ACR build. So we're going to build our image. After we've told it the image that we wanted to build, we basically provided a registry that we want to store it in, and give it a tag and a version number. So we'll let this finish building, and then I'll once again show you how the file was built. Matter of fact, I'll just do it right here. So what we'll do, once again, the Docker file will go through each step. It will run an npm, it'll copy the contents, it'll start it, building it, and then what it'll do is have all of our different pieces of our application saved and then put into a container image. So we are almost done. It's building our container image. And now that it's building our container image, we actually need somewhere to host it. So what we're going to do is we're going to go to the resource group that we created before. What we'll do is we'll click Add. and we're going to use this web app. And then within here, we're just going to give our web app a name. And so I'll give my web app a name of web app TWT, web app Tailwind Traders. So we have the option of picking a runtime stack, and you can see there are all these different runtimes, but we're going to be using a container that we'll build on our own. We're going to select Linux. We'll pick where we want to store it. We've got all these options, or host it, but I'm going to use East US. And then we need an actual hosting plan with the type of hardware, resources, the compute that we need. So we'll go ahead and we'll create one. We'll call it TWT app plan. So what we can do if we want to is look at these different types of specs, all these different hardware types. We'll just use the default. There's a free one if you'd like to use it. Next we'll go to Docker. Here's where we're going to get the option of picking the container we just created. So we're going to use a single container. We're not going to use a Docker Compose file. That's if we wanted to have multiple different containers with different things installed on it. We're not going to use a quick start. We're going to use our Azure container registry. We're going to pick the registry we just created. There is our image. There is the tag number. So let me show you the actual image information that I created before. So here it is. It's going to build everything that we asked for, all of our environment, all of our information around our container. It's going to start it, and then eventually it'll store it, and once it's finished being stored, it'll be right here. And if we wanted to put a particular startup command, we could. This is the tag of the version number of the instant image we're going to be using. So now we can use monitoring. We can't use application insights. That's embedded into the specific runtime stacks. You can check it out. It gives you a lot of information. Now we can click Review and Create. So it's going to give you all the information about our Docker container that's being created, the image, the tag that we're going to be using, the server URL when it's built, and then all the other information. So what we're going to do is just click Create. And so now we're going to go through the deployment process. And let's talk about what's going on right now. It's going to build our infrastructure. It's going to build all the different parts of the app that we need. And then eventually what it's going to do is it's going to provide us with our hosting space. So you can see, I love the fact that you can see all these things being created. And if you wanted to, you can actually save the deployment file. Look, it's already done. So we can save the deployment information and redeploy it using an ARM template. I'll give you some information in the links about ARM template in our deck info. So we've gone ahead and we've finished deploying our application. We have all these options around our container settings that if we have a new version of the container, we can set up continuous deployment so that a new version, when it comes out, it'll be put as the newest version. We've also got this deployment center that if we want to implement Azure DevOps, we can do that. So we need to kind of finish some stuff for our app to get it to work. And like a lot of different applications, we need to have environment variables set. So I'm going to set a few environment variables. In this case, I'll do new application setting. And so I need to set what is the API URL location. So right there. And this would be the URL. So we'll put that there. Excuse me. And then we'll just click OK. And so we can save a number of these. Just click Save. And then these are turned into environment variables. So I'm going to show you one that I've already completed that has all of our environment variables in it, and show you that when we're complete how our app looks. So we've got our two databases right here. We've got our ACR. This is a virtual network. This is a network which we can use for all of our private traffic. This is our actual SQL database right here. Here's our service plan, and then here's our app service. So let's go into the app service. Remember, I showed you those environment variables. Well, here's all of them. And that includes our information for our product images, our SQL connection string that we got from the SQL service, and then our MongoDB connection string we got from our Cosmos DB service. So once that's all said and done, we can go to Overview, click URL, and our application has been migrated and is online. Now we can go to App, Add to List, Buy a Product, and we're done. So let's go ahead and finish up, all right? So you noticed I really didn't talk about Kubernetes, and there's a reason behind that. Is that Kubernetes isn't all that containers is. It's a very, very popular but a little bit more complex way of using containers. You can find out way more from all the different resources on Azure, including you can use the MS Learn collection of different modules. It's free. It's education that you can get anytime, any place, interactively. You can check out our docs. We've got all these different quick starts and information on containers. Take a look at it. And then, so here are your session resources again. If you want, you can use the session code, get $200 free Azure, and start using this. So I will stick around for Q&A in the chat. And if you have any comments, feel free to reach out to me on Twitter. Talk about how much you enjoyed this session. So make sure that when you build something and when you create, you do it with purpose. And that's what we want to help you with at Microsoft Azure. So thank you very much. My name is Jay Gordon. I hope you learned something. I'll see you next time.